Hello, welcome back to another episode of Math with Haas. You are watching Precalculus Season 2, Episode 1. In this very first episode of Season 2, we are beginning our discussion of trigonometry. And trigonometry begins with, it begins with circles and exploring relationships of ratios. But before we get there, we have to first consider how to find the equation of a circle. And before we do that, we must even figure out what is called the distance formula. Now, when we consider 2 points A and B, or as more standard notation, P and Q, the question is, how do we find a distance between P and Q? How far is this line segment that connects our 2 points? That is the question. Now, if we had 2 points on a nice straight line here, like if this was our P and this was our Q, we'll just call it A and B. The distance from A to B, we use this notation right here, AB. When it's a nice horizontal line, we've previously learned that, or I should say, we should have previously learned in algebra class that the length of this line segment would be the absolute value of, so in this case, we have just x coordinates here, so I would say x1, comma 0, and b would be at x2, comma 0. Then we could say the distance is the absolute value of x2 minus x1, and that would tell us what is the distance between A and B. The problem now, though, with P and Q is that it's a straight line, but it's also a diagonal. So how we want to think about this is, what if we had a triangle instead? So for example, if I was to draw a line straight down and a line straight across, well, then we would have this nice right triangle. And if this is a right triangle, well, then we do know that if this was a and a B and a C here, using our notation, we know that from Pythagorean theorem that a squared plus b squared is equal to c squared. So if we can figure out what a and b is, then we could figure out how to get the length of the hypotenuse, which is our distance from P to Q. So let's go ahead and put some coordinates on here. I'm going to say that P1 is at the value x1, y1, and Q x2, y2. Alright, now when we think about this point over here, we'll call it, how about R? Why not? Just give it some name. When we think about R, since we are straight across from P to R, the y coordinate doesn't change at all. So we know that this is going to have the coordinate y1. And when we think about the x coordinate in relationship to P, or not P, but Q and R, notice it's straight up and down, so the y value, or the x value, is not changing. So that means R is going to be at x2, y1. Alright, now if we recall what I said earlier about the distance between 2 points that are straight, we said it was just the absolute value of those values, right? So if this is x2, this would be x1. Absolute value gives us that distance. We can now use that idea to get how far to get the distance from P to R. Since P to R is this nice horizontal line, we know that the distance from P to R is x2 minus x1. So distance from P to R, we know, is going to be the absolute value of x2 minus x1. Similarly, distance between Q and R is going to be the absolute value of the y coordinates, y2 minus y1. Alright. Now, we can reinterpret the Pythagorean theorem here, right? Because we could think of this as, instead of a, b, and c squared, I'm going to rewrite this down here. We could think of our c squared, we could think of it as really as our distance from p to q. That quantity is squared. We could think of our a as the quantity of the distance from p to r. What's here? A. No, that's q to r. Oops, my bad. Let's see where it's at. Q to r. We can think of it as this quantity squared. And we can think of b as quantity of distance from p to... Ooh, I almost put q, but that needs to be an r. From p to r. That quantity squared. So, why don't we think of it this way? Then we can substitute in our absolute values in for a and b. So a is going to equal absolute value, or instead of absolute value, we can drop it now since the quantity is being squared. And b is going to be, what's here? Oh, whoops, I got that backwards again. Alright, let's see where I set it. There we go. So since a is the distance from q to r squared, that's going to be y2 minus y1, that quantity squared. And for b, it's going to be x2 minus x1, quantity squared. And we can drop the absolute values because both of these differences, the x2 minus x1 and y2 minus y1, those are both being squared, so it's going to be positive anyways. That's why we can drop those absolute values. So with these new way of thinking about a, b, and c here in terms of distances, we are going to reinterpret the Pythagorean theorem. So we have the distance from p to q, quantity squared, is equal to, I'm going to rearrange my a and b. I'm going to write my b first, so x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. Now, since the original question was, what is the distance from P to Q? Since we want to figure out what that distance from P to Q is, all we have to do is now square root it, okay? I put the A, B, and C squareds on top just to remind us what those three quantities are. So, if I square root both sides, well, here we are, our ginormous square roots. And that tells us that the distance from P to Q is going to equal the square root of x2 minus x1 quantity squared plus the difference of y2 minus y1, that quantity squared. And this thing right here, we can highlight it. That is called the distance formula. So, this is our new first fun fact. This is the distance formula. So, define the distance between any 2 points. We can use this formula here. So, for example, if I have a point P at, how about 1, -5, and Q is at, how about -11, -12. Then if I want to know the distance between these 2 points, all I have to do is first draw a ginormous square root, but then I want to look at this and say, well, x2 minus x1, so this -11 here, that's going to be my x2, -11, minus my x1 right here. So here's my x2, here's my x1, that quantity is squared, and then now I need my y2 minus my y1. So we need a quantity of -12 minus -5. So one thing you can notice here is there's going to be a lot of negatives. You have a negative already in the formula here, and then if your points have negatives, you're going to have a lot of negatives to keep track of. So be sure to write them all down and take it nice and slow. So when I look at these two negatives here, that double negative means this is now going to be a plus, and I'm going to scratch that out. So negative 1 minus negative 11 is negative 12, that quantity squared, plus, then we have negative 12 plus 5, so that's negative 7 quantity squared. This is still square rooted. Now, one thing to note about the TI-84 is this particular curiosity. So if I plug in negative 12 squared like this, and I hit enter, I get negative 144. What the heck? Now, you know that should be the wrong answer, because when you square a number, it should be positive. Unfortunately though, some of my students I've had in the past do not catch this, and this every year is something I have to explain, and it's a good thing to explain to all of you now. So how the graphing calculator works on this, so we're going to do this off to the side. What it does is it sees this negative, and it sees a square, and what it does, how the calculator interprets this is it will take 12, it will square it to give you the 144, but then secondly applies the negative. So in other words, how the calculator is programmed is it does the square first, and then it takes care of the negative second, or last in this case, which is why we get this erroneous answer here. I do not know why Texas Instruments did that, but it seems kind of silly, and it's a common mistake with students. So if you want to figure out what negative 12 squared is, in case you didn't know what it was, you need to put parentheses around all that, hit square, hit enter, voila, we get our positive 144. So that is a danger of the TI-84 graphing calculator that you need to be aware of. So we got 144 plus 49 inside our square root, and so let's figure out what that is. See here, 193 should be. I'm going to verify 193. All right. Now 193, we can probably factor it, though it doesn't look like anything nice. Let's see, is it divisible by 7? Nope. Is it divisible by 11? Nope. Oops. I wonder if it's a prime number. Divided by, how about 19? Nope. Well, we can just run through everything. I know it's not going to be divisible by 3. And if you're wondering, the easy way of knowing the number's not divisible by 3 is you go 1 plus 9 plus 3. This is equal to 13. 13 is not divisible by 3. Therefore, 193 is not divisible by 3. That's one cool fact about that. About being divisible by 3. Let's see, did we do 13? No, we didn't do 13. Let's check out 13. Nope. We did. Did we do 17? Nope. Okay. So what we're doing is just going through a list here, right? In this case, a mental list times 17. So let's see here. We're going to verify now using the internet. Is this a prime number? It is a prime number. Alright, that'll explain why running through the primes we didn't get anything. So this will be our answer here. There's no need to reduce that. Alright. So let's go ahead and do another example. Alright. So suppose we have values, how about 5, negative 5, and how about 3, comma 2. Alright, so the distance from P to Q, we want square root, then we want to think x2, so that's the 3, minus x1, that's the 5, that quantity has to be squared, then plus, now we have the 2 minus negative 5, and that quantity is squared. So let's see here, we get negative 2 quantity squared plus 7 quantity squared, which gives us 4 plus 49 being square rooted. That's a terrible looking 9 and 4, so let's make that better. So this will give us square root of 53. I wonder if that's an odd prime number. Just our luck, another prime number. I guess that's pretty good for just picking values off the top of our head, getting 2 primes. Alright. Usually you have to do some work to break down the square roots. And you're probably wondering what I mean by that. So if, for example, if you had something like square root of 32, right? We'll put a box on it. That's our answer. So if we had square root 32 as our answer, we need to reduce that down. So 32, we can notice that it's divisible by 2. So if we divide 2 out, there's 2 and 16. Well, I know that 16 is 4 times 4. So if I think about this, it's the same thing as 16 times 2 square rooted, or square root 16 times root 2. That gives you 4 root 2. So if you had an answer like root 32, you would have to reduce it down like this. In our 2 examples, however, we had prime numbers, so they didn't reduce down. Alright, we'll call that a video. We're just going to focus strictly on the distance formula in this one. In the next one, we will apply the distance formula to determine what is the equation of a circle. If you've enjoyed this video, please consider subscribing to our channel and supporting us on Patreon. Thank you for joining the math party, and I will see you next time.